Our problem.
Take two.
Our problem is we have to find the mass of an ellipsoid, 4x squared plus 4y squared plus z squared equals 16, where the density of rho is given by rho of x, y, z is equal to x plus y plus z plus 10. And normally, the mass of the ellipsoid would be found by mass equals density times volume, or m equals rho times v, and that's for a constant density. But we don't have a constant density. As you see, rho is a function of x, y, and z. So our mass equation is mass equals the triple integral of rho of x, y, z, and it's whatever, it's not always x, y, z, it's whatever variables are there, and dv for variable density. And dv, if you go over here, could equal any of these in any order: x, y, z, x, z, y, y, x, z, y, z, x, y, x, z. I already said that. That's supposed to be z in front. Okay. But it could be any of these three, dx, dy, dz, in any order. And so when you translate it to this, you plug in for dv. You get the triple integral, and there's going to be limits there, of x plus y plus z plus 10 with d whatever order you want to do it in. dx, dy, dz, dy, dx, dz, whatever it is. And letter A asks us to solve it for dz, dx, dy. So to make finding the limits easier, what I did is, if you look at this ellipsoid I drew out, with three axes, you're able to kind of see that this is one section, 2, 3, 4, and that is split by these axes, so that's 5, 6, 7, 8 because it's flipped. So you split it into 8 different parts, one here, 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 one here. Yeah. So that's 8 different parts of the ellipsoid. So when you do that, you're able to do 8 times, and that makes the limits much easier to solve for. It makes all the bottom limit 0 because you're starting from the origin right here in your ellipsoid. So it makes all the bottom limits 0. And now when you're solving, it'll be just like Ravi's problem to figure out the limits. What we're going to do is we're going to take the original equation we have with 4x squared, 4y squared, 4z squared, and we're going to plug in to solve for it. So what I like to do is I start with the farthest integral away, which is x. And when you're solving for that one, all the other variables are going to become 0. So it's 4x squared plus 4 times 0 squared plus 0 squared equals 16. And obviously these two are going to become 0. So you're left with 4x squared equals 16. You divide by 4. And you're left with x squared equals 4, because 16 divided by 4 is 4. You square root that, and you get x equals 2. So that's our upper limit for this x integral right here. We have x equals 0 to x equals 2. And now you do it for y, but this is in terms of y and x. So you're going to leave x in it when you solve for y. You're going to go 4x squared plus 4y squared plus 0 squared, because that's supposed to be z. But we're not using z right now, so that's 0. That's going to go 0 again. And we're solving for y, so we're going to subtract 4x squared to the other side. And that's going to leave us with 4y squared equals 16 minus 4x squared. And then we're going to divide by 4. And we get y squared equals 4 minus x squared. And then we're going to square root that. And we get y equals the square root of 4 minus x squared. And that's our upper limit for y. So y equals the square root of 4 minus x squared for the upper limit, and the lower limit is still y equals 0. Now we're going to do it for z, but all 3 variables are going to be involved. So I'll do that down here. We're going to have 4x squared plus 4y squared plus z squared equals 16. And we're solving for z squared. So we're going to subtract 4x squared, and we're going to subtract 4y squared. And we're going to be left with z squared equals 16 minus 4x squared minus 4y squared. And we're able to square root that, and we get z equals the square root of 16 minus 4x squared minus 4y squared. And that's the upper limit for this one. The square root of 16 minus 4x squared minus 4y squared. And from there, I actually end up going through most of it by hand, but not all of it. But you plug into the calculator, and you'll get 8 times still. So you have 8 times, and when you evaluate this, you'll get 104 pi over 3. So our final answer will be 832 pi over 3. And that's our volume. Any questions on part A? No? Okay. Do you want to go through part B? Or no?
Is it the same thing?
It's the same exact thing. If you switch the variables, you're going to do the same exact thing, except we're going to solve them in a different order. So if z was first, you do this exact thing, except for do 0, 0, and z.
Oh, okay.
And I had to solve it from the outside in because that makes the most sense to me. So all of your answers should come out to 832 pi over 3. And if they don't, then you did it wrong. So that's my presentation.